Welcome to This Explainer. Today, we're doing something pretty wild. We're journeying back to the very beginning of absolutely everything. We're going to unpack a really profound mystery: how our highly ordered universe, with all its perfectly balanced galaxies, stars, and planets, somehow managed to emerge from a state of absolute unyielding chaos. Picture this. It's just moments after the Big Bang. If you were somehow there to look around, you would find absolutely no stars, no galaxies, and not even a single atom. There was literally nothing that we would recognize as matter today. Instead, just a massive, violently expanding ocean of pure energy and fundamental particles, all just waiting to take shape. Physicists actually call this starless void the cosmic soup. And it's a pretty fantastic term because, much like a real soup, it was this seemingly chaotic, messy state that actually hid all the precise ingredients needed to build the cosmos as we know it today. It was completely wild for sure, but it was absolutely full of potential.
So you might be wondering, what was stopping all these ingredients from simply snapping together right away? Well, the main culprit was extreme heat. And I don't just mean the intense heat you'd find inside the core of our sun. We are talking about temperatures exceeding trillions of degrees. This unimaginable heat turned the young universe into this hyper-energetic plasma, which is a state of matter completely unlike anything we interact with today.
Inside this blistering heat, the environment was, frankly, incredibly violent. Particles were constantly colliding, shattering, and transforming into one another. Because of this cosmic demolition derby, the early universe was filled exclusively with the absolute smallest fundamental building blocks, things like quarks, electrons, neutrinos, and photons. The energy was simply way too high for anything larger or more complex to survive those collisions. But thankfully for us, the universe didn't stay in this hyperheated state forever. As it rapidly expanded outward, it naturally began to cool down. And this drop in temperature is the absolutely crucial driving force that allowed stable matter to finally take shape. The heat was backing off, and those fundamental building blocks could actually start getting to work. Here's where the magic really starts. As the cosmos cooled, the first major structural changes kicked in. First, quarks started to combine and lock together to form protons and neutrons. Then, in a process physicists call nucleosynthesis, those protons and neutrons fused together to create the very first hydrogen and helium nuclei. And amazingly, all of this happened within just the first few minutes of the universe's existence. Just a few minutes. Yet even with these atomic nuclei successfully forged, we still had a problem. Complete atoms couldn't exist yet. Basically, we had the center of the atoms, but we were completely missing the outer shell. The electrons were still just far too energetic, buzzing and zipping around with way too much speed to get captured by the gravitational pull of those newly formed nuclei. Because of these unbound, free-floating electrons, the universe entered a really unusual phase. It was filled with radiation, meaning it glowed brightly with intense energy. But despite all that brilliant light, the universe remained entirely opaque. It's crazy to think about, but if you were there, you wouldn't be able to see a single thing. The reason for this is that photons of light couldn't travel freely. Every time a photon tried to move forward, it would immediately crash into and scatter off one of those wild, free-floating electrons. So the light was physically trapped, just bouncing endlessly in place. It behaved exactly like a flashlight shining through a thick, dense fog. So light is literally trapped, and this dark, foggy age dragged on for a very long time, until a massive transition occurred roughly 380,000 years after the Big Bang. That 380,000 mark is the magic number. At this point, the universe had finally expanded and cooled down just enough to trigger a monumental cosmic breakthrough. In an instant, the whole game changed. The cooling universe allowed those hyperactive electrons to finally slow down and click into place with the waiting nuclei. This created the very first stable atoms. And because the electrons were no longer flying around freely acting as roadblocks, the fog instantly cleared. The universe became transparent, and light was finally able to travel freely across space. That exact moment of sudden transparency is monumental for us today. Think of it like the universe taking its very first baby picture. That newly freed ancient light from the clearing of the fog didn't just disappear. It's been traveling through space ever since, and it is exactly what we observe and study today as the cosmic microwave background. It is the literal afterglow of the universe's birth.
Actually, fun fact, if you've ever seen the static on an old analog television set, about 1% of that static is literally this exact ancient light hitting the antenna. How cool is that? Okay, so with stable atomic matter now populating a beautifully transparent universe, the stage was officially set. The chaotic energy had finally been tamed into organized matter, and now gravity could take over. Gravity began to pull on this newly formed matter to start building the massive, complex structures we recognize in our night sky today. And how did gravity pull this off? It exploited tiny imperfections. These little density fluctuations, basically tiny clumps of matter left over from those earliest, most chaotic moments, began to grow stronger and heavier under the pull of gravity. Over millions of years, this matter evolved into giant, sprawling gas clouds that would eventually compress, heat up, and ignite as the very first stars and galaxies. Now, why this all matters to you and me is profound. Without this quiet, critical transition from chaotic energy to stable matter back in the days of the cosmic soup, absolutely nothing familiar would exist. There would be no atoms to build with, no stars to provide heat, no planets to stand on, and for sure, absolutely no life. It was a messy beginning, but a perfectly necessary one. So, look at the incredible journey we just took. If the universe naturally evolved from a chaotic cosmic soup into a highly ordered cosmos, is complexity simply an inevitable outcome of the laws of nature? Or is something more required to explain how such intricate order emerged from absolute chaos? I'll leave you with that massive thought to ponder until our next explainer, where we're going to take the next giant leap in cosmic history and witness the birth of those very first stars. See you then!